Hello, what's going on, Gracians? This is the Scientific Mind, and I'm your teacher, Sir Eman. For those who don't know me yet, this is my short profile. To start our episode, let's have our prayer first. Before we jump to our discussion, let me show you what you need to accomplish for this week. After watching the video about Earth on day 1, you are going to answer this worksheet entitled Interstellar Crash Landing. So you will see a table entitled Factors that make a planet habitable. So there are factors here: temperature, atmosphere, energy, and nutrients. And the criteria. For criteria, which is not enough of the factor, just right, too much of the factor, situation in the solar system. Procedure 1. Choose among the planets below is habitable and reason why you choose that planet. Reason why you did not choose other planets using the table above. Which among of these planets is habitable? And reason out why you chose that planet. Also, you are going to reason why you did not choose other planets using the table above, using this table. On day 2, you are going to write an essay about terraforming Mars. Write a 200-word essay or report on the following topic. Can man alter Mars' environment to make it more suitable for human habitation? How? After that, you will answer this concept map about Earth subsystems. Direction: explain the connection of each Earth subsystems with each other. After watching the video about common rock-forming minerals, you are going to answer this activity entitled Mineral Properties. Using a Venn diagram, describe 2 household minerals commonly found in your household. Name at least 3 similarities and differences between your chosen minerals. So you can research names of household minerals commonly found and you can choose 2 among them and differentiate the 2. On the last day, you are going to answer this rock summary question. And you have 7 questions. You are going to answer these questions. Make sure that you finish all those activities before the deadline. Okay, so let's go back to the Earth and start our discussion. Earth, its characteristic and subsystem. For the first part, we are going to talk about the characteristic of Earth that makes life possible. So what is Earth? It is the third planet from the Sun and the only object in the universe known to harbor life. It is the densest planet in the solar system and the largest of the 4 terrestrial planets. Other terrestrial planets involves Mercury, Venus, and Mars. So what is unique about Earth? First, the proximity to the Sun. Earth is located in the Goldilocks zone, which it is not too hot or too cold. Next is the existence of water at the Earth's surface, neither too much nor too little. That is in the liquid form. Earth's size is just right, large enough to hang on its atmosphere but not too large to hold on too much atmosphere and consequently too much heat. Next is the system of plate tectonics that enables the carbon silicate cycle regulating the temperature. And it has a protection from the Jupiter, whose gravity helps divert and vacuum the incoming debris like asteroids or meteors and keeping the Earth safe. Next, the only moon and its stabilizing effect on our planetary rotation prevents the pole from shifting unexpectedly. What are these characteristics that makes Earth capable of supporting life? We have the water, atmosphere, and plate tectonics. Water. Water is the only substance on Earth that is in liquid form at room temperatures, commonly found on the surface of our planet. Other liquid substances on Earth may turn into solid or gas when they are in the room temperature. Next, water is an excellent solvent capable of dissolving many substances, and it covers 70% of the Earth's surface. Next is water is a superb solvent, meaning that other substances regularly and easily dissolve into it. This allows water to carry nutrients to cells and carry waste away from them. Next is plate tectonics. Plates cover the entire Earth and their boundaries play an important role in geologic happenings. The movement of these plates atop a thick fluid mantle is known as plate tectonics and the source of earthquakes and volcanoes. It is vital for the world to host life. A planet whose shell is broken up into plates that can constantly move around. Atmosphere. Earth's atmosphere is contains 78% nitrogen, 21% oxygen, and 1% argon. Earth's atmosphere blocks some of the sun's dangerous rays from reaching the surface. It traps heat, making Earth a comfortable temperature. Earth and its major systems. So what is a system? A system is an organized entity that consists of interrelated and interacting components. Physical systems have matter and energy as well as an organizational structure consisting of pathways and linkages between components. Our planetary environment, the Earth system, includes interactions among a vast combination of factors. The individual components of a system interact with each other as a part of functioning unit. The Earth system consists of four principal subsystems: air, water, land, life. Each helps shape the structure of the planet. So what are these subsystems biological components of the Earth system? The biological components of Earth as systems are often referred as spheres and subdivided into four. First is geosphere, which consists of the solid earth like landforms, mineral, rocks, and soils. Next is hydrosphere, which includes the waters of earth such as ocean, lakes, rivers, glaciers, and water in the soil, atmosphere, and organism. Third, atmosphere. It is a gaseous blanket of air that envelopes, shields, insulates earth. Variations in atmospheric components and processes create the changing condition that we know as the weather and climate. And last, the biosphere, which is composed of people, animal, plants, and all other living things. These major subsystems and the interactions among them nurture the conditions necessary for life on Earth, but the impact and intensity of those interactions are not equal everywhere. This inequality leads to our planet's environmental diversity and produces a wide variety of geographic patterns on Earth. These four major subsystems do not function in isolation in each other. Instead, they interact, overlap, and are complexly interconnected. Geosphere. So let's talk about the four subsystems. Let's start with geosphere. Geosphere is considered that portion of the Earth system that includes the Earth's interior, rocks and minerals, landforms, and processes that shape the Earth's surface. It makes up the solid portion of the Earth's layer, Earth's structure, and land. Layers of the Earth. The outermost layer of the Earth is called the crust. Crust has a thin layer measuring 40 km deep composed of solid rocks and minerals. It is divided into two parts, the oceanic crust and the continental crust. Oceanic crust is the uppermost layer of the oceanic portion of a tectonic plate, while the continental crust is the layer of igneous, sedimentary, and metamorphic rocks that forms the continent and areas of shallow seabed close to their shores known as the continental shelves. Next layer of the Earth is the mantle. It represents about 85% of the total weight and mass of the planet that can be found between the core and the crust. What composes the mantle? The first 50 miles of the mantle is a very hard, rigid rock. The next 150 miles is a superheated solid rock, and the next several hundred miles is a solid, sturdy rock material. The mantle is divided into two, the upper mantle and the lower mantle. Upper mantle extends from the crust to a depth of about 410 kilometers or 255 miles. The upper mantle is mostly solid, but its more malleable region that contributes to tectonic activities. Next, which is the lower mantle. It extends from about 660 kilometers or 410 miles to about 2,700 kilometers or 1,678 miles beneath Earth's surface. The lower mantle is hotter and denser than the upper mantle and transition zone. The lower mantle is much less ductile than the upper mantle and transition zone. Although heat usually corresponds to softening rocks, intense pressure keeps the lower mantle solid. Next layer of the Earth is the core. Scientists believe that deep down inside the Earth, there's a huge ball of liquid and solid iron. This is the Earth's core and it protects us from the dangerous radiation of space, and also divided into two parts, the outer core and the inner core. Outer core is a fluid layer about 2,300 km or 1,400 miles, thick and composed of mostly iron and nickel that lies above the Earth's solid inner core and below its mantle. Its outer boundary lies 2,890 km or 1,800 miles beneath the Earth's surface. Inner core or the Earth's inner core is the Earth's innermost part, and according to seismological studies, it has been believed to be a solid ball with a radius of about 1,220 kilometers or 760 miles, which is about 70% of the Moon's radius. It is composed of an iron-nickel alloy and some light elements. Next subsystem is hydrosphere. Hydrosphere is the combined mass of water found on, under, and above the Earth's surface, minor planet or natural satellite. Mostly 70% of Earth is composed of water. 97% of Earth's water is in the form of oceans or salty, and the rest are fresh water or non-salty. Cryosphere is the portion of the hydrosphere which is frozen, such as glaciers, ice caps, and icebergs. Hydrologic cycle or water cycle. In the hydrologic cycle, water from oceans, lakes, swamps, rivers that turns into water vapor is done in the process of evaporation. If the water that turns to vapor comes from plants, it is known as transpiration. After the process of evaporation or transpiration, the water vapor condenses into a million of tiny droplets that form clouds, or the process of condensation. Clouds lose their water as rain or snow in the process called precipitation. Next subsystem is the atmosphere. Earth's atmosphere is not just merely the air that we breathe, but also a blanket of gas that surrounds our planet up to the edge of space. Earth's atmosphere is mostly composed of nitrogen, about 78%, oxygen, about 21%, argon, about 0.9%, with carbon dioxide and other gases in trace amounts. So what are the layers of the atmosphere? So let's start from the very bottom. Troposphere extends 6 to 20 kilometers high, considered the densest among other parts of the atmosphere. In this sphere, all weather types are found. Next, going up is the stratosphere. Extends up to 50 kilometers high. In this region, we can find the ozone layer, which absorbs and scatters the solar radiation. Moving up is the mesosphere. Extends 80 kilometers high. In this section or in this layer of the atmosphere, meteors burn up as they approach the planet. Up above the mesosphere is the thermosphere. Extends up to 600 kilometers above the mesosphere. It is where auroras or the northern lights and satellites are located. The satellites that I have mentioned here are not the natural satellites, but the artificial ones that checks or observes the weather pattern or climate change. Up above the thermosphere is the exosphere. This is the upper limit of the atmosphere, which extends from about 10,000 kilometers above the thermosphere. On the outermost part of the atmosphere, we can find the ionosphere. It extends about 48 kilometers above the surface to the edge of the space up 965 kilometers. It is the part where the abundant layers of electron, ionized atoms, and molecules occur. The last subsystem of Earth is the biosphere. It is also known as the zone of life. In this part, life exists. Biosphere is unique. So far, there has been no existence of life elsewhere in the universe. Life on Earth depends on the sun. Energy, which is provided by the sun, is captured by plants, some bacteria, and protists in the marvelous phenomenon of photosynthesis or the food processing of autotrophs. The captured energy transforms carbon dioxide into organic compounds such as sugar, then produces oxygen that are being used by humans in the process of respiration. The vast majority of species of animals, fungi, parasitic plants, and many bacteria depend directly or indirectly on the process of photosynthesis. These Earth's four major systems do not function in isolation of each other. Instead, they interact, overlap, and are complexly interconnected. Water of the hydrosphere flows through organisms, including people, and provides habitat for aquatic plants and animals within the biosphere. The hydrosphere interacts with the lithosphere in many ways, such as streams, waves, and currents shaping landform. Water also has important connection with the atmosphere through evaporation, condensation, and effects of ocean temperatures on climate. Many other examples exist of connections and interactions among the four major Earth subsystems. Soil can be examined from the perspective of the lithosphere, biosphere, hydrosphere, and atmosphere. Because soils typically contain minerals, organisms, water, and gases. The water in clouds is simultaneously a component of both the hydrosphere and the atmosphere, and water stored in plants and animals is part of both hydrosphere and biosphere. The fact that we cannot draw a sharp boundaries between these subsystems underscores the interrelatedness among various components of the Earth's subsystem. Earth system is dynamic, responding to continuous change. Because of this, some of these changes occur frequently or proceed at an appropriate speed for people to easily observe them. Okay, so that ends our episode for today. I hope you learned some new knowledge from me and you enjoy watching. This is The Scientific Mind with Sir Eman, and goodbye.